And we are going to move on today to this theorem, which says how to find the integral of a constant. So by now, just like we did before, when I said derivative, what does that mean? Slope. When I say integral, what does that mean? Area. Okay, so integral just means area. Now, what does constant mean? Constant is like f of x is equal to some number. So for example, suppose I have f of x equals, I don't know, 4. Okay, what does that look like? Well, that looks like, if this is x and this is y, that looks like that, right? Okay. Now, suppose this is 0 and this is, I don't know, 8. Okay? And I wanted to find the area underneath here. What shape do I have? A rectangle. Really, it doesn't get any better than that, right? And how do I find the area of a rectangle? Base times height. So think of it as, okay, how would a 4th grader find this area? Base times height. And here the base is 8, right? And the height is 4, all right? Well, in calculus, instead of saying find the area of, I could just say, okay, the area from 0 to 8 of 4 dx. That tells me find the area of this thing created from 0 to 8 of y equals 4. Okay, and I say, that has a base of 8 and that has a height of 4, so that must be 32. Okay? So now, if I were to ask you, find the area from 2 to 7 of 4 dx, what would you do? How much is the base? 5 times 4 this time, 20. All right? So just base times height. So this is what all this is telling us. Okay? If you have a to b, f of x dx, f could be anything. It could be a constant. And then how do you find the area of that? Well, it's that height, right? This becomes the height. And then this, so this becomes the height, and this becomes the base. Okay? All right. So remember in 5.1, there was this train that was moving steadily, blah, 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 right? At a steady rate of 75 miles an hour from 7 a.m. to 9 a.m. And now we wanted to find the total distance. And we said when we have a graph of time versus velocity, that the distance is the area, right? So to remind you guys, this is what that looked like. T and velocity, and it was moving at 75. And we wanted to find the area from 7 a.m. to 7 p.m., the distance. So, now it's 7 a.m. Oh, it was 7. Was it always 7 a.m. to 9 a.m.? All right, we'll do that. 7 a.m. to 9 a.m. We did a different one that was 12 hours, right? Yeah. Okay. So, so the calculus way of writing this is, okay, 7 to 9, all right, of 75. And what's the variable here? T. So dt. And that's just equal to the height of the rectangle, gentlemen, times the base. Okay? And that's equal to 150 miles. Now, somebody's going to ask me, do we really need to write 9 minus 7? Not really. You know, just do it. Yes?
Quick question. This was one of also on the homework. There's X and then there's T. So when we're doing like these types of problems.
No, just leave it as X.
Oh, it's the same.
That T is for a different mode if you're in parametric mode, which don't bother.
Okay,
Yeah.
But on the paper we should T.
Yeah.
Okay.
Okay, so here, if we want to evaluate each of these integrals, this is going to be super, super quick. So it's just this number, -6, times 7 minus 3 is 4, -24. That's it. That's it. I know. Here, pi over 2, pi is a number, pi over 2 is still a number, right? So this is a constant. So this is recognizing that this is a constant. So it's going to be pi over 2, that's the height. And then the base here is -1 minus 4. Okay? Always do this like, you know, with the formula, right? Because the sign will matter. Sign will matter whether you're going left or right. And then this is going to be 3 pi over 2. Okay? Right? Should we put in more steps here or we go? Okay, let's see. So this is pi over 2 times 3, which is 3 pi over 2. 3 pi over 2 is much better. Okay. Next, we've got some basic shapes. Okay? And if it says use the graph of the integrand and areas to evaluate each integral, I want to see geometric area formulas. Okay? Geometric area formulas. So here. All right, so this word integrand. Integrand is the function which is being integrated. So basically, this is an operator, just like plus minus is an operator. This is an operator. This is sort of part of that. So this symbol we'll talk about later and dx are attached to each other. All right. What goes in the middle, this filling, that's the integrand. All right. Huh? Yeah. Okay. All right. So why don't we graph this? Negative 2x plus 4. So here. And then we go down 2 over 1, down 2 over 1. So right there. That's how I graph that line, right? Negative 2x plus 4. I know, but I want it to graph the whole thing. Just so. Okay. All right, so that's what the line looks like. Okay, now let's go back to what I'm asked for. I'm asked for the area from 0 to 1. So the area from 0 to 1 is this. Okay, what shape is that underneath? That's a trapezoid. So now if it says use areas to find it, the formula for a trapezoid, for the area of a trapezoid, is half times height times base 1 plus base 2. So half, what's the height here? 1. Remember, for a trapezoid, the height is what? The distance between the two parallel sides. Good. Half times 1 times base 1 plus base 2. Okay? And so that's 3. Question? Huh? All right. Here, 1 minus absolute value of x. All right, this is an absolute value of x problem. I'm sorry, a graph. What does an absolute value graph look like? It's a V. This one's going to be facing down because it's negative x, but it's up 1. So basically, here and here. All right, that's what it looks. That's what it looks like. Now, I want the area from negative 1 to 1. From negative 1 to 1, that's what that looks like. All right, now, okay. When we're looking for area, you always go between the graph and the x-axis. So here, we're not going to find, all of this area. That's infinite, right? So just know that you have to stop at the x-axis. So it has to be between the graph and the x-axis, all right? Well, what is that? That's a triangle now, right? So that's going to be half times the base is 2 times the height is 1. So that's 1. On a quiz or test, I'm going to be looking that you've used the formulas for area. So write down, at least that step for the work. All right? Okay, here. using your graphing calculator. So let's do that. Huh? Yeah, you're gonna have a calculator available on the quiz. So these on the calculator, you wouldn't need to show any work, and it'll be stuff that you can't do by hand anyway. So right now you don't know how to do x times sine x by hand. Okay? So look, I already have this here. All right? I go up, I press the up button, I go over there, I press enter so I recall this, and then I try as much as possible to edit. So here, which one? Oh, I don't have that one here, but I'll show you. Math 9 works as well, right? Yeah. Okay, so here it's going to be x sine x. And, whoops. And here we're going to go to -1. All right, any answers?
Yes.
What do you have? 2.043. I have 2.043. Any other answers?
Same.
2.043.
Negative 2.04.
Because
Negative.
Jillian, yours is negative because you switched these. -1 has to be on the bottom, 2 has to be on top.
Negative 1 goes first.
-1 goes first.
Okay.
That's why it switched. Okay, if you've got the older version, then you're gonna do, so you have f int, or is it function integrate? You're gonna do x sine x comma x comma -1 comma 2. It has to be the lower number first, then the upper number. All right? So the syntax, the way it works is, what function are you integrating? What is the variable of the function? And from what to what is your range? All right? So, yeah. So math 9, you get this one, from 0 to 1, 4 over 1 plus x squared.
You don't need any parentheses in there?
Not for the 4, but for the 1 plus x squared I did put parentheses, yeah. dx. Put parentheses. Hey, what do you get for this, guys? That's a pi. That's pi. Huh? No, you won't get points off. But that's pi. Isn't that cool? Isn't that cool that if you integrate 4 plus 1 over 1 plus x squared, you get pi? Come on, that's really pretty cool. Okay. Find points of discontinuity on the integrand on the interval of integration and use the area to evaluate the integral. Okay, many words here. Find the points of discontinuity of the integrand of this function on the interval of integration. All right? We're integrating from -1 to 2. We're integrating from -1 to 2. So now this is telling you, see if there are any points of discontinuity on that interval. Because if there is a discontinuity at x equals 5 or at x equals -10, I don't care, right? Okay, so we're going to graph this. Think about this function for a minute. The top will always give you a positive value. The bottom will be positive for positive values, negative for negative values, and there's a 1 relationship in there. So if you graph this, it looks like this. Okay? But at x equals 0, does this exist? No. because it's 0 over 0. So that's what it looks like. All right? And you can graph it and you can find out. You would have your calculator available with you. But I'm just saying, right, no matter what you have the same value over the same value. 5 over 5, negative 5 over 5. So you're always going to get a ratio of 1. It just matters if it's positive or negative.
Again, it's just -1. Right?
Yeah. Yeah. Is it on this or is it on a calculator? Yeah.
But you graph it on the calculator,
Yeah.
just plug in what's in the parentheses
No, x over x, absolute value x over x and y. Yeah, so you graph it. Okay. All right, so we're going from, since we want to use area, we're going from -1 to 2. So I want this region and I want that region. Okay? So the way I write it is this. From -1 to 2, absolute value x over x dx is equal to the area here, right, is how much? Is 1 and 1, but there is a negative in front of it, right? So it's -1 times 1. And then here, this has positive area, 2 times 1. So in the end, it's 1. So this is one where, even if you have the calculator with you for the entire test or quiz, I would be, if it says to use the area, that I need to see this work. All right, because you have to justify where this came from. If you have just this and you were able to have your calculator with you, this will not get full credit. Okay, so I want to see, or you could do the positive area first.
Do we have a calculator
And then okay, hang on. Or you could do the positive area first and then the negative area. But I need to see this. Okay? Question.
Yeah, so